A very good morning to everyone. I myself Ankan from CSC department second year. Firstly, I would like to thanks to Sir Somoji Sir for giving us the opportunity to introduce our topics, conservation robotics. Here is my teammate Sudip, Kundu and Ayush Saha. Now let's go through the contents. Here is the content: introduction, application of wildlife conservation robotics. After that, key robotics technologies in wildlife conservation, advantage of robotics in wildlife conservation, success stories, and then challenges and ethical consideration, and then the other parts: conclusion, reference, and acknowledgement. And now I start the. Now we will explore this fascinating area in the coming minutes, and learns how robotics is become an essential tool in our mission to protect the biodiversity of the world. So first of all, we come to the introduction topic. That first question came in our mind, that what is robotics and where it is uses. So basically robotics is the field of technology and engineering focused on designing, building and semi-autonomous machines. These machines carry out duties in a variety of areas including manufacturing, healthcare and many more. Now we discuss about our main topic, that what is conservation robotics. So conservation robotics is the application of robotics technology in various aspects of conservation and environmental management. It aims to address conservation challenges by using robots to monitor, survey and protect wildlife. Now we come to the application part. In this picture you can see that there is a endangered species of animals like majestic elephants, the Indian bison, snow leopard and blue whale and many more. And besides there is a graphical representation that in 2007 the endangered species is around 7,851, but year by year it is rising. It rises, and in 2019 it is almost around double, and it is around 14,234. So that is a main problem. So to solve it, conservation robotics plays a vital role in safeguarding endangered species. By utilizing advanced technologies, it tracks and monitors these species, collecting vital information that ensures their long-term survival in their native environments. Then we come the next points, that habitat restoration and management. So AI and autonomous devices are used in conservation robotics to monitor, repair and protect ecosystem. These technologies improve data gathering, the preservation of species and overall environmental health, allowing the long-time preservation of biodiversity and the recovery of ecosystem. Now we come to the next slide, and it is disease detection and control, human wildlife conflict resolution. By improving disease diagnosis, conservation robotics helps to maintain the health of wildlife. It makes use of data to find solution of problems between people and animals, fostering interaction and successful conservation that benefits both species and ecosystem. And we then comes to the next slide, and it is anti-poaching efforts and law enforcement. So in conservation robotics, drone and AI-driven surveillance are beneficial for law enforcement and anti-poaching. Through enhanced investigation, detection of illegal activities and the preservation of endangered animals, this technology supports efforts at wildlife conservation and law enforcement. Now I am going to present a video about anti-poaching efforts. So in this video we see that how robotics detects anti-poaching activities and informs to the forest police to catch them via GPS. Now I am going to invite Sudip Kundu for further presentation.
Thanks, Ankan. Now I will like to continue with key robotic technologies in wildlife conservation. First point is GPS-enabled tracking devices. Second is unmanned aerial vehicles, drones or surveys, autonomous underwater vehicles (AUVs) in marine conservation, and robotic wildlife rehabilitation.
High-tech tool on a mission.
Okay. Now let's see a video of a robot which is used in Atlanta Botanical Garden for monitoring one of the endangered species, that is a sloth bear.
High-tech tool on a mission to save the world's most endangered species. Built by engineers at the Georgia Institute of Technology, it's currently being tested in the Atlanta Botanical Gardens forests. But why would anyone want to create a robot that moves as slowly as a sloth?
Idea to the sloth bot actually came when I was in Costa Rica, when I got mildly obsessed with sloths, because I could not understand how these creatures can exist, right? They're just...
High-tech tool on a mission to save the world's most endangered species. Built by engineers at the Georgia Institute of Technology, it's currently being tested in the Atlanta Botanical Gardens forests. But why would anyone want to create a robot that moves as slowly as a sloth?
Idea to the sloth bot actually came when I was in Costa Rica, when I got mildly obsessed with sloths, because I could not understand how these creatures can exist, right? They're just...
Now is unmanned aerial vehicles or drones for surveys. Robotics is the study of robots, which are machines that can be programmed to perform a variety of tasks. Drones, also known as unmanned aerial vehicles or UAVs, are a type of robot that can be controlled remotely and are used for a variety of purposes, such as to gather data about wildlife, population, habitats, and ecosystems. Here's how drones are used in wildlife surveys. First is aerial surveys. Drones can cover large areas of land or water quickly and efficiently, providing researchers with a bird's eye view of environment. This is particularly used for counting wildlife populations, such as counting herds of animals or colonies of birds. Next point is habitat mapping. Drones equipped with high resolution cameras or LiDAR sensors can create detailed maps of habitats. This information helps researchers understand changes in vegetation, water bodies, and land features, which is crucial for conservation planning. Now, a question may arise that what is a LiDAR sensor? So, LiDAR or light detection and ranging sensors are remote sensing devices that uses laser light to measure distances and create detailed 3D maps of objects and environments. They work by emitting laser pulses and measuring the time it takes for the light to bounce back after hitting the object. This information is used to calculate distances, create highly accurate representation of surfaces and surroundings. Now next point is nesting site identification. Drones can help locate nesting sites of birds, turtles or other animals that are difficult to spot from the ground. This information is vital for protecting these sensitive sites. Now is GPS enabled tracking devices. As you can see here, a GPS enabled tracking device in wildlife conservation refers to a device equipped with global positioning system GPS receiver that is used to monitor and track the movements of animals in their natural habitats. These devices are often attached to animals such as mammals, birds, and even marine species, and provide researchers and with valuable information about the animal's behavior, migration patterns, and habitat use. Here's how GPS enabled tracking devices are typically used in wildlife conservation. First one is data collection. The GPS enabled tracking devices records animals' location at regular intervals, which can range from seconds to hours depending on the research goals and the device's battery life. Next point is behavioral studies. Researchers can analyze the collected data to understand various aspects of the animal's behavior, such as feeding habitats, mating behaviors, and more. Next is migration patterns. GPS tracking devices are particularly used for tracking animal movements over time. Researchers can identify migration routes, stopover sites, and potential threats along the way. Next one is habitat use and preferences. The data collected from GPS enabled devices can help researchers understand an animal's preferred habitat and the factors that influence their choices. Oh, so this is a video of an agile robot keeping an eye on Italy's forest.
The conservation status of habitats is primarily assessed by humans, in particular human operators that has to go in the environment and check the conservation status of it. At the moment, there are also other technologies that allow us to perform similar tasks, but actually this kind of system has the ability to move freely in the environment because it is a legacy system, so it reproduces the human locomotion system and in general the animal locomotion system. So it is very agile and it is also able to walk over really irregular and rough terrain.
So now is autonomous underwater vehicles or AUVs in marine conservation. Autonomous underwater vehicles or AUVs are specialized robotic vehicles designed for marine exploration and research. These vehicles are capable of operating underwater without direct human control and can perform a variety of tasks, making them valuable tools in marine conservation efforts. AUVs are equipped with sensors, cameras, and sometimes manipulators, allowing them to collect data, capture images, and even interact with marine environment. Here's how AUVs are used in marine conservation. First point is habitat mapping. AUVs are equipped with sonar systems and cameras that can create detailed maps of the sea floor and underwater habitats. Next one is coral reef monitoring. Coral reef monitoring. AUVs can capture detailed images of coral reef, assess their health, and monitor changes over time. This information is essential for tracking the impact of climate change, pollution, and other stressors on coral reef ecosystems. Fisheries management. AUVs equipped with acoustic sensors can help researchers estimate fish population and by detecting counting fish in a given area. This data is used to inform sustainable fisheries management practices. So you may not know about the acoustic sensors, so let me explain about it. Acoustic sensors are devices that detect and measure sound waves or acoustic signals in the surrounding environment. These sensors are designed to convert sound energy into electrical strengths, which can then be processed and analyzed. They find various applications such as in industrial monitoring, surveillance, and medical equipment. Acoustic sensors can be used to capture and analyze sound patterns, enabling the identification of specific sounds and measurements of noise levels. Next point is oceanographic data collection. AUVs can gather data on water temperature, salinity, currents, and other oceanographic parameters. This information contributes to our understanding of ocean dynamics and how they can influence marine ecosystems. Next point is deep sea exploration. AUVs are used to explore deep sea environments that are difficult or dangerous for humans to access. They can explore hydrothermal vent systems, underwater volcanoes, and other unique ecosystems to study their geology, chemistry, and biology. Now let's see a video. this is about robotic wildlife rehabilitation. Robotic wildlife rehabilitation is an emerging field that combines robotics technology with efforts to rehabilitate and care for injured animals. Traditional wildlife rehabilitation involves human caregivers providing medical treatment, shelter, and food to the animals in need. Here are some ways robotic technology is being explored in wildlife rehabilitation. First one is animal prosthetics and orthotics. Roboticists and veterinarians collaborate to develop customized prosthetic limbs or orthotic devices, as you can see here, for animals that have lost limbs or suffered injuries. These devices can help injured wildlife regain mobility and functionality. Next is remote medical treatment. Robots and remotely operated vehicles can be used to administer medical treatments such as wound cleaning or medication delivery to wildlife in hard to reach areas or those that are difficult to handle. Next point is behavioral studies and rehabilitation training. Behavioral studies and rehabilitation training. Robotic animals or devices can be used to mimic the behavior of certain species, helping to train animals or for release back into the wild by teaching them essential survival skills before they are released. These are some pictures of robots that are used in wildlife conservation. These are all terrestrial robots. Now let's see a video of robotic animals that could be used in wildlife conservation.
तो ये देखिए एक चीता रोबोट है जो बॉस्टन डायनामिक्स अमेरिकन कंपनी के द्वारा बनाई गई है। ये ट्रेडमिल के ऊपर उसको टेस्ट किया गया। देखिए कुछ इस तरीके से ट्रेडमिल के ऊपर चल रहा है। ये आउटडोर में चल रहा है। बहुत ही शानदार, बहुत ही अच्छी बनावट। ये स्पाइडर रोबोट है। ये देखिए कितना बेहतरीन, ये खूबसूरत तरीके से क्लाइंब करते हुए
So these robotic animals can mimic the behavior of original animals. So we can use this in wildlife conservation. And now Ayush will continue with the further presentation.
Thank you, Sudip. Without any delay, I will continue the further presentation. So our next slide is about the success stories. And here we will see how robotics technology make a difference with others and in which cases we currently use this robotics technology. So first is monitoring tiger with camera traps. There is a system using AI and IoT which can give the access to patrolling in a vast area in a jungle. Okay, let's see a graph. In the graph, this is made by the Indian Wildlife Institute. In 2006, the number of population of tiger is 1,400, near about 1,400.
and then after the first intelligence server when applied in 2014, the number of population is increased to 2200, and later when the robotics technology is attached to that, then it becomes the 3600. So it is a increasing graph, we can see. Then we use the robotics also in the conservation of rhinoceros from poaching, using drones to combat rhino poaching in Assam. Here is a bar graph in which we show the last 15 years rhino poaching, number of rhino poaching in Assam. So in 2013 the number of rhino poaching in Assam is 41. But when the first AI plus radar technology, which is also known as the Simulink technology, is invented, then it becomes 9 to 6 in 2017 and 2018. But when it attached to the robotics technology, means 2021 and 2022, it is almost the negligible. That means it is 10 to 1. Then now we see a video.
Or the next trophy mount. But if some unlucky hunters find this guy, then they're about to have a bad day. What helps us is distance from the roadway. That's what helps it make it look more real than it may be. Meet Robbie, the robot deer. He's used by the Sarasota County Sheriff's Office to catch hunters who illegally shoot on private property. It's a stuffed deer that can be controlled remotely. Deputies can turn its head and flick its tail.
I can have the deer facing away from them, and then when they make a noise, I can have that head turn towards that noise.
Deputies say during the fall, some hunters trespass onto private property and shoot deer from their trucks. So officials place the robot deer about 80 yards from a road. Then they'll hide nearby and watch.
We get guys that shoot it multiple times, and unlike a real deer, it doesn't run off. And then they'll make comments, about it being a dumb deer. They can't believe it's still standing there. I can't believe I missed the shot.
Once they shoot, it's considered a third-degree felony. So deputies will follow them and arrest them.
These robotic deer are completely customizable. They can add moss to the antlers to appear more natural, or they can even remove these antlers, turning this buck into a doe.
Ranchers worked hard for their land and for the right to hunt their own game. This robot deer puts a stop to these crimes, and prospective criminals should always think twice before pulling that trigger.
Isn't that pretty neat? The Sheriff's Office has 3 of those deer in use, and as you can imagine, after it's put into work, it's badly damaged. And
So as we can see from this video that there is a robotic deer, and it helps us to find the poachers and the hunters. Now we coming in the part of coral reef restoration. So in this picture we can see there is some robots which provide some information about the underwater sequence, about the health of the coral reef, about the pH factor, about the water temperature, about the acidity, alkalinity, and according to that data the management of the forest department or the water department works on it. Now this is the most common uses of the robotics, that is the endangered birds conservation. The bioacoustic scaring system produces a warning call whenever a hunter or a poacher comes into the village. The birds get a warning alarm and they scary away in the jungle. And here is a picture which is a small machine and basically a spy type device that provides some feeds to the bird and also gives the alarming sound to the bird. This machine is also known as the bird buddy. Now no doubt AI, IoT, robotics are the best for our future, but it has also some challenges, some ethics. First of all, it is tough to balancing the technology advancement with the ethical concern. Then its potential disruption to the natural behavior. It means when we use robotics, there must be generate some signals or some networks, which is very harmful for the birds or the animals. According to a survey, it is seen that if any animal live in a networking zone more than the 8 years, then it average lifetime will decrease 7 to 8%, and also seen that also seen that there is some change in their natural behavior. Then the data privacy and security for sensitive wildlife information. It means it is important to keep the data very safe, because generally the poachers, the hunters, the surveillants are try to catch the data, crack the privacy and hack the information. So it is very important to save the data privacy. And the next one is the unemployment and de-skilling of the workspace. For using the robotic system, it is generally known that it creates a lots of unemployment, and it also affects in our economy, and that also the race laborers are not very well skilled and not very well trained, so it creates a lots of problem. In conclusion, through the lens of the aerial drones, we can use the robotic system, but it is a very, in one word, it is a very good to observe the robotic system. It is very good to use the robotic system, but it is also an endangered one for the endangered species. So we have to use it, but in a limited way. Here are some reference: the Google, YouTube, Canva, Wikipedia, and ChatGPT. I will thankful to my. Thank you, sir. Thank you.